right, next we're going to look at multiplying and dividing roots that have different roots. So we're going to come up with a technique such that we can multiply a square root to a cube root. So what we're going to do is we're going to convert our radicals into fractional exponents, and then we'll convert it back. So my first problem, there's a 2 on that square root. So that fraction would be x to the 3/2 power. This x has a 1 as its power, so that's x to the 1/3 power. So if you multiply like bases, you add your exponents, 3/2 plus 1/3. So we need a common denominator. Multiply the 2 times the 3, that will be my LCD, that will be a 6. So this fraction needs to be multiplied by 3 over 3. This fraction needs to be multiplied by 2 over 2. So that will be 9/6 plus 2/6. 9 plus 2 is 11, so 11/6. And now, once we have this x to one single fractional exponent, we rewrite it as a radical, 6 root of x to the 11th. But now we can use your Gazinta rule. 6 goes into 11 once, so we'll take out 1x, but then there's 5 x's left over, so x to the 5th on the inside. Next example, convert them all to fractional exponents. A to the 2/4, b to the 3/4, times a to the 1/3, times b to the 2/3. There they are. Now, what I would do is group the a's together. A times a, add those exponents. A to the 2/4 times a to the 1/4, add those together. 4 times 3 will be 12, so we multiply 3 top and bottom. The 1/3 multiply 4 top and bottom. B to the 3/4 times b to the 2/3, common denominator 12. The fourth, 3 over 3, is multiplied to 3/4. 4 over 4 is multiplied to the 2/3. This will change all your denominators to 12s. 6/12, 4/12. Don't cancel anything. We want everybody to have a denominator of 12. Over here, 3/12, 8/12. Now we add together. 6/12 plus 4/12 is 10/12. 9/12 plus 8/12 is 17/12. Again, don't reduce. We want the denominators to be the same, so we can rewrite this now as the 12th root of a to the 10th, b to the 17th, and we can use our Gazinta rule because 17 as a power is bigger than the root. So 12 goes into 17 once with b to the 5th left over, and there's our final answer. We can do the same with binomials. This would be the x minus 2 to the 2/3 power. This is x minus 2 to the 3/4 power. My bases are the same, so we're going to add our exponents, 2/3 plus 3/4. So again, 12 is my least common denominator. So we're going to multiply the 2/3 by 4 over 4, the 3/4 by 3 over 3, like we did over here. We're going to get 8/12 plus 9/12, 17/12. Converted back into the radical, 12, the 12th root of x minus 2 to the 17th power. 12 goes into 17 once, so we'll take out x minus 2 to the 1st power, and we have x minus 2 to the 5th power left over on the inside. Now, fractional powers is a very nice way to do this because everything is straightforward, but there's a lot of steps. There is a shortcut. So I'm going to bring this problem down here. I'm going to put all the numbers in here, and I'm going to discuss the shortcut. I notice that my root became a 6. Well, if I have a square root and a cube root, you just multiply the roots together, and that's going to be your common root. This is the 6th root of x to the something. Now, where did the 11 come from? Well, if you look at your fractional powers, the 3 over the 2 was multiplied by a 3. Okay, where did that 3 come from? That came from this root. And then the 1 right here was multiplied by 2, which is the root of the second one. So next is you multiply the first power 3 times the second root. 3 times 3. Then you're going to add to that the second power 1 multiplied by the first root 2. Add those together. 9 plus 2, there's your x to the 11th, and then we can simplify it right here. 6 goes into 11 once with 5 left over. All right, let's do that with this problem. Again, putting a 1 because I didn't put an exponent. Common root, 4 times 3. It's going to be 12. Then it's first power times second root, 2 times 3. Then it's second power. Oh, I guess we're doing the b's. So 3 times this 3 is this for this b. Then it's the 1 times the first root, 1 times 4. And then it's 2 times the 4 for the b's. So 6 plus 4 is 10. 9 plus 8 is 17. There's that radical right there. And then, of course, we simplify it. All right, so we'll practice some of those again, but we're going to do this in the form of division. So if we had to divide different roots, again, fractional powers, put a 2 there, a 1 there. X to the 4/5 divided by x to the 1/2, now you subtract your powers, but you need common denominators. 5 times 2 is 10, so this fraction gets multiplied by 2 over 2. This fraction, 5 over 5. You're going to get 8 tenths minus 5 tenths, which is x to the 3 tenths, which then converted back to the radical is the 10th root of x to the 3rd. We can do that in our next example as well. We'll have a to the 5/4, b to the 3/4 over a to the 3/7, b to the 4/7. Dividing like bases, subtract the powers. So this is a to the 5/4 minus 3/4, b to the 3/4 minus 7/4. 28 is going to be my least common denominator. So first fraction, 7 over 7, is multiplied to 5/4. Then 4 over 4 is multiplied to 3/7. 7 over 7 is multiplied to 3/4. 4 over 4 is multiplied to 4/7. So this now becomes 35 over 28 minus 12 over 28. 21 over 28 minus 16 over 28. We subtract the tops. 35 minus 12 is 23. 21 minus 16 is 5. This becomes now the 28th root of a to the 23rd power, b to the 5th. And again with binomials, this would be x plus y to the 5/6 power, x plus y to the 3/4 power. Divide like bases, subtract your exponents. So 5/6 minus 3/4, now my LCD would be a 12. So we'll multiply the first fraction by 2 over 2, second one by 3 over 3. We'll get 10/12 minus 9/12 is 1/12, which becomes the 12th root of the x plus y to the first power. Now, that same multiplication pattern can work here for division. However, you got to be very careful in your alignment. So again, multiply the roots. 5, the 5th root of x to the 4th, over again, put the numbers in square root of x to the 1st. Multiply the root numbers. We have the 10th root. Start with the top power, because remember, we got to subtract going down. 4/5 minus 1/2. So 4 top power top power times bottom root minus, so 4 times 2 minus bottom power 1 times top root 5. 8 minus 5 is the 10th root of x to the 3rd. There's my answer. Working with this one here, okay, 4 times 7, 28th root. Top power 5 times bottom root 7, 5 times 7, minus bottom power 3 times top root 4. Then your A is done. Then we do the same with the B. So B, top power 3 times bottom root 7, minus bottom power 4 times top root 4. 35 minus 12, that's the A to the 23rd. 21 minus 16, there's the B to the 5th, and we're done. Over here, 6th root, 4th root. Multiply those together to get the 24th root. Top power 5 times bottom root 4 minus bottom power 3 times top root 6. So that becomes 20 minus 18, which is the 24th root of x plus 2 squared. But because both the power and the root are even numbers, we can reduce it by 2, because again, you can think of this as x plus y to the 2 over 24th power, reduce it to 1/12, and then 12th root of x plus y to the first power. So if you can't divide the root into the power, but if you can reduce it, you are welcome to do that. And that wraps up how to handle multiplying and dividing radicals with different roots.